Right. Good morning. You're good evening.
My mom told me the class started at 12:30. Wait, next time you should send it to me.
I sent it to you today, but
Yeah,
morning,
you
not
didn't send it
yesterday. Just check your messages. I send it to you, but after sending your mother, no one joined. Then I send it to you.
Oh yeah. See, yeah, you need to send it to me first.
Yeah. You first. Yeah, okay. Next time I'll do it.
Okay.
Your mom missed the time.
Yeah.
No, the problem today I have another work after the class. That's why we'll see. Otherwise, it's okay. Even starting at 8, it doesn't matter.
Mm-hmm.
Last time we start polymers, ne? We did some polymers, ne?
Yeah.
We talk about some polymers, ne? What are the polymers we talk about? We
We
talk about addition polymers, ne?
addition, yeah, addition polymers and low density polyethylene.
Low density polyethylene. Right. Low density polyethylene, ne? Right. Then we have talk about common addition polymers, right? So basically, just get the idea. When we say addition polymers, these polymers contain double bond, right? These
Mm-hmm.
polymers contain a double bond, right? That double
Yeah.
bond goes to the polymerization, right?
Mm-hmm.
Those polymers adding, right? When something adding into the double bond, we call addition, right?
Yeah.
We call it addition, right? So this polymerization happened like that, right? Double bonds open and then they are joining, right? There's another type called condensation, right?
Yeah.
Condensation, there is a water molecule release when they join, right? Here nothing release, right? They just open the double bond and then binding, right?
Mm-hmm. Yeah.
So let's talk about PVC, right? Vinyl chloride. In the exam, generally they ask some these kind of questions. They give the monomer, right? You know what is monomer, right? This is monomer,
Yeah,
right?
it's a unit.
They,
A unit of
yeah, the normal molecule like this, and they ask the polymer or the what type of polymerization happen, right? Or the type of the polymer, right? You can say addition polymer, right? When you look at the if you saw a double bond, you can say it's addition polymer, right? And they may ask the polymer, what is the polymer and the reaction, something like that, right? That's a common type of question. And they may ask the properties of that special type of polymers, right? What type of properties, right? Those that kind of questions are very common in the exam, right?
yeah.
So here, this one called polyvinyl chloride. Sorry, vinyl chloride, right? Here it's chloride. This kind of, when double bond connected into this one, we call vinyl, right?
Mm-hmm.
So when it's polymerized, this double bond open and this is the polymer. We don't know how many molecules in that specific polymer, right?
Yeah.
Especially in a polymer, um, generally molecule has a molar mass, right? This molecule has a specific molar mass, it's a constant, right? But when you come to polymers, can you say specific molar mass for a polymer? You
No.
can't. The problem is we don't know how many monomers connect together. I guess, did I explain that last day? We can't say exact molar mass, right? Generally, we explain those, I mean, express those molar masses as a, I mean, range, right? We say the molar mass should be this ranges, right? Something like that, right? I mean, in higher advanced polymer parts, I mean, not here, I mean, not in your level, but in advanced polymer, they talk about those things, right? We can't express the exact polymer molecule, right? Because each
Yeah.
polymer molecule are different, right? And depend on the conditions that we supply, the size of the molecule will change. Sometimes one polymer molecule have 10,000 molecules, sometimes 5,000, sometimes 20,000. It depend, right? And depend on the size, their characters also change, right? If the polymer molecule is far too long, it may hard, right? I mean, it gives some characters depending on the polymer. Likewise, okay. So
Yeah.
keep it in your mind. There's no any exact formula, right? That's why we put N, right? If 10 molecules polymerize, the polymer molecule has 10 monomers. Likewise,
Yeah.
that's why we put N, right? So this is called monomer. This is called polymer. This is the polymer molecule, right? This is the polymer molecule. And there's another one called repeating unit, right? Difference between repeating unit and polymer. In the repeating unit, we don't mention N, right? Because this part is repeating continuously, right? This is the part continuously repeat, right? Therefore, we
Yeah.
call repeating unit, okay? Right. Write down a sentence. Polyvinyl chloride. Polyvinyl chloride formed by polyvinyl chloride formed by polyvinyl chloride formed by polymerization of vinyl chloride. Polymerization of vinyl chloride. Just write down the equation. Right. Right. Then so we talk about ethene, right? We talk about ethene and then write down polystyrene. Next type, polystyrene. Polystyrene also same type. The difference is in polystyrene, here there is a benzene. Give me a second. Right. So what would be the polymer? Basically, it has several. If they ask to join several molecules, which is called, I mean, styrene, right? This is benzene, nah? This is benzene. Or maybe they write something like C6H5, right? Same thing, huh?
Yeah.
Oh, this. They draw the similar structure like this. C6H5, right? Same thing, huh?
Okay.
Similar. So how it's joined? can write it generally like this. Right? When you write, and just keep it in your mind. Never put, I mean, consider about the carbon number. You can't put 5 carbons or 7 carbon likewise, because it's always multiplying by 2. Okay,
Oh,
keep it
okay.
in your mind. Huh?
Okay.
Don't put 5, 7 like numbers, right? Just when you draw the structure, keep the structure in your mind. Huh? Otherwise, it's wrong. This is styrene, right?
Okay.
Write down. Huh? Draw
Mhm.
the diagram.
I did it.
Right. Then next one, tetrafluoroethene. Tetrafluoroethene, right? Tetrafluoroethene. This one also called Teflon, right? I
Okay.
talk about this one, right? So this is the one used in non-stick pans, right?
Mm-hmm.
Non-stick pan, they use this, right?
Yeah.
Tetrafluoroethene or Teflon, right? So it's toxic, right? I mean, nowadays, uh, I mean, they found out it's toxic, and so this is the basic one, Teflon. They do some changes for these polymers, not only Teflon. I mean, for those polymers, they do some changes, right? This is the basic one.
Mm-hmm.
Then they develop the characters, right? So then the importance of tetrafluoroethene, it's not combustible, it's not burn, right? Why?
Yeah.
It's contain fluorine, right?
Mm-hmm.
The carbon bonded with fluorine, right? Then it's not combustible. Combustion means reacting with oxygen. Then it's bind with fluorine. It's not react under normal conditions, right?
Okay.
So that's the most important part. It's heat resistant, right? It will melt but not burn.
Yeah.
Right. Then people use it as a non-stick material, but later found out it's a toxic for human body. Right? Still we use it, right? still,
Mm-hmm.
still we don't stop using that, right?
Yeah.
Even if they ban, you know what happened when they ban something like this chemical, right? What happened most of the time, what they do when any government ban this kind of compound, they
Yeah.
altered the compound little bit, right? They
Oh yeah.
altered the compound little bit. What happened? Basically, nothing happened. I mean, something happened, but it's negligible, right? I mean, changing a compound little bit, it's not a matter. It's not a big
Yeah.
matter, right? Sometimes it's big matter, but they know how to change it, right? Very small
Yeah.
changes, right? Then what happened? They introduce it with a new name, right? Then what happened?
Mm-hmm.
Then it takes another 5 10 years to find out whether it's toxic or not, right?
Yeah.
Most of the time that one also toxic, right? After bearing that, they do the same, right? That's how the companies work, right? Most of the time. There are some things, I mean, those are very close, I mean, changing little bit, but it's become totally different now. example, uh, you know, cholesterol. You heard about cholesterol, right? And vitamin, cholesterol and vitamin D, right? Cholesterol and vitamin D. Have you heard about you can get vitamin D when you under sunlight?
Yeah.
Huh? Yeah.
Yeah.
So most of the time, I mean, especially in I mean, your countries like your countries, I mean, they just stay under sunlight also, right? I mean, they do it for get tan color, ne? Right?
Yeah.
Right. We also tan. We already tan, right? We don't like to go under sunlight, right? So what happened? The theory, they said when you under sunlight, you can get vitamin D, and actually that's the way we get vitamin D early days, right? I mean, we didn't have any tablets, right? Early days, people went outside, right? There's no any IT people early days, right? No one is stay at, I mean, no one, they have work to do in out, right? Outside. Not like now, I mean, people can't stay inside those days. So they got vitamin D when they exposed to sunlight, right? How? Vitamin D and cholesterol are very similar molecule, right? There
Yeah.
are a lot of similarities. There's few changes, right? So you don't need to know the structure and those things, but the basic idea, when sunlight falls, when you expose to sunlight, when that cholesterol exposed to sunlight, how cholesterol exposed to sunlight? Your skin contain cholesterol, right?
Yeah.
Then sunlight have specific waves that can change that cholesterol molecule, I mean the part of cholesterol molecule, especially functional groups, right, into vitamin D structure, right? When UV falls into the cholesterol, it converts into vitamin D. Those molecules are very similar, right? That change into one, I mean change into vitamin D due to that small light, right?
Yeah.
So that's what happened, right? So that kind of changes happen. I mean, those when those molecules are very similar, we can change it, right? But it's
Yeah.
completely different one, right? So you need cholesterol, right, to get vitamin D. I mean, you need cholesterol. Your brain completely filled by cholesterol, right? Cholesterol is not a bad thing, right? So tetrafluoroethene. So write down this one. And so what are the characters? There are some characters, special characters, right? Non-stick, we talk about it. Heat resistant, yeah, we talk about it. Chemical resistant, again, correct. I mean, it's chemical resist. I mean, it not degrade, right? Because it's
Yeah.
bonded with fluorine, right? No one can remove fluorine. That's the important here, right? Then good mechanical properties, strong, durable, right? Flame resistant, unflammable. We talk about that, right? Okay. Here there are some common polymers, right? Tetrafluoroethene, no need to talk about everyone, right? So just read that table 384, right? So if they gave a, even if they gave a new monomer with a double bond, you should be able to make the polymer structure, right?
Yeah.
You can, right, just open the double bond and then combine, right? It's easy, it's not a hard thing, huh? Then write down the main topic, condensation polymers. This is new, huh? Condensation polymers. Condensation polymers. Condensation polymers. Condensation polymers, right? Here, this polymerization happen with the release of water, right? That's why we call condensation. Then guess what type of compound release water when they combine? What type of functional groups? I'm talking about what type of functional group? Huh? You learn.
Which
You
functional
know the
groups do we
basics.
know?
Huh? Uh-uh.
Uh, Probably like,
Alcohol.
yeah,
Alcohol and what?
and like COOH.
Ah, right. COH, basically, right? So when compounds have that kind of groups, they can polymerize by releasing water molecule, right? Here we talk about that type of polymers, right? Here the difference is in previously we polymerized same molecule, just one molecule, right?
Mm.
Right, just I mean you just polymerize this one, ethene, right? This is the only thing, right, you need. But condensation, most of the time you need two compounds and we use two compounds, right? We
Yeah.
combine two compounds, right? Not only two molecules, but I mean it's continuously joining. So for condensation polymers, generally we use two compounds, right? So write down the definition. in condensation in condensation polymers, in condensation polymers,
Mm-hmm.
we use two different type of molecules, two different type of molecules. When sorry, during polymerization, no, oh, no, wait, um, these molecules combined, these molecules combined, these molecules combine by releasing water molecules. These molecules combine by releasing water molecules, right? So it doesn't, I mean, whatever you use for this process, it should have what? So the middle part, it doesn't matter, right? It can be whatever, right? Anything, it can be anything, but the end should have this kind of structures, right? I mean, this is one example, right? So this is one monomer, monomer one. Then another type, this is the most common type. The middle, whatever, right? Whatever, middle, it doesn't matter. We don't care. Then monomer 2, right? Then what? Then these two can join. This is normal monomer. This can be any hydrocarbon, right? It, whatever, right?
Yeah.
Hydrocarbon or any compound with something like carbonyl group, right? Whatever, right? The middle part, it doesn't matter. We don't care, right? But it's become a problem in the middle part if middle. But the the rule is you can't contain. I mean, you can't put any COOH groups, huh? Right?
Yeah.
Except COOH OH, you can put anything as a middle part, right? You can choose anything. Like that thing. So what is the repeating unit here?
Monomer.
You can see the repeating unit is this whole set. I'll continue for next time. So what's the repeating unit? This one, right? Starting from here to, sorry, here to here. Right? This is the repeating unit. Can you see the green color?
Yeah.
Is it clear? Sometimes it's not clear. That's why I don't use that. If it's clear, good. Right? Repeating unit. Right? Right? So that's how it's happened. Right? So both sides have the same. Right? Sometimes, I mean, this is a common type. Right? You can use, right, anyhow both side should have alcohol or carboxylic group. If only one side contain, we can't do polymerization, right? Both sides should have the OH and COOH, both are right. Okay, write down this one. Is it clear? Can you write it? Can you draw it along?
Yeah.
Right? The middle part, it can be anything, huh? This is a common type, right? The middle part can be anything, right? C2H5, CH3, right? Anyway, it doesn't matter. Right. So, what are the differences between condensation polymer and this one, basically? In condensation polymer, I mean, addition polymer. In addition polymer, what happened? It's need the double bond, right? I mean, here You don't need that type of unsaturation, right? Addition polymers based on the unsaturation, right? Without unsaturation, it's not happen. Then here, there's no any unsaturation. I mean, unsaturation doesn't matter here. So, in addition polymers, is there any byproducts? Byproducts? No any byproducts, just addition, right? No any byproducts. Here, what is a byproduct? Water is a byproduct, right? Water molecule is removing, right? These two combine.
Yeah.
Right. Water molecule is removing. So in addition polymers, the monomers form bond with carbon, right? CC bonds, right? During
Yeah.
polymerization, new CC bonds are formed, right? But here, not CC bonds, right? It forms CO bonds, right? Clear? New CO bonds, not CC. This one bond with oxygen. But in addition, it's CC bonds, carbon-carbon bonds, right? So those are the main differences between condensation and addition, right? Condensation polymers are important because we can join two different monomers, right? That's why it's important. When we goes to addition polymers, we can't join two different monomers, right? We just multiply the one single monomer, right? That's why condensation polymers are important. You can join whatever you need, right? Then you can, how it's important. Let's say one polymer has, let's say there is a polymer which is, this is hard, right? This polymer is hard. And there is a polymer which is elastic. It has elastic property. This one is hard. So hard one is not elastic, right? Then what will happen? You can mix those together and then you can get a new property, right?
Yeah.
Which is a little bit hard but is stretchable, right? Understood? That's why it's important. You can mix, when you mixing, it's like you got the characters from your mother and you got the characters from your father, right? So
Yeah.
father is little bit, right? You can understand, right? So if your mother is angry, your father is not angry, then you are in the middle, right? Not too much angry, not too much soft, right? Something like that. The same thing happened to the polymer, right?
Yeah.
Right. So keep it in your mind, differences.
Yeah.
Then let's move to another real polymer, real condensation polymer. This is the basic, I mean the type, basic way it's form. So the first one, polyethylene terephthalate. Right, those names are kind of hard. Polyethylene. So polyethylene terephthalate. Polyethylene terephthalate we call PET. We call PET plastic, right? Have you heard about PET plastic?
Yeah.
So this type, have you seen this kind of one in the water bottles? There's a triangle and in middle one.
Oh yeah.
One time is right. So that's it, right? Basically, you see this polymer among water bottle. I mean the plastic water bottles, that one time use portables in the shops, right? Drinking
Yeah.
water, right? So they use this type of bottle, right? So what is the polymer here? I mean the monomer. Right. Can you make the polymer structure?
Okay.
Write the polymer structure. Not two, not two. Four. Combine four monomers, right? To this one and two, I mean two. What is the name of this? I don't know. Right? This one and this. Combine several monomers and make a final structure. Just draw it. I'll come in a second. right? What kind of structure? Right, so here, what is the monomer? Sorry, I mean polymer. Sorry, repeating unit. So you can draw repeating unit like here, or you can draw it from here to here to here. Oh, yeah. This is the repeating unit. Yeah. These polymers are longer
Yeah.
than my previous one. I mean addition polymers. Then this is repeating. Then so where is the bond? This is the ester bond. These are the ester bonds, right? I'm just describing ester bonds. Right? These are ester bonds. Esterification, right? Right. Then I just mentioned the places that esterification happen. When they combine anything, right? That joint is esterification, right? Okay, clear?
Yeah.
So whatever they give, you have to follow the basically in your case, yeah, that there are two types, right? I mean esterification, right? Condensation polymers based on esterification, and then the next one may amide, forming amide, the same thing happened, right? We learned two different condensation reactions earlier, right? Esterification is one, then other one carboxylic group and amine group, remember? Nitrogen with NH3 one, this one, RNH3, NH2, this one. These two also combine with carboxylic acid, right? Releasing H2, right? So these are the two types that you learn, right? Two type of polymers, right? Based on esterification, and other type is this forming amides, right? This one is clear, right? Nothing to
Yeah.
explain, clear. This one is clear, right? So then the next one, write down nylon. Wait, where are we? You should know some places we use this one. Just write down uses, uses, uh, the drinking water bottles. Sorry, what you call that, normal water bottles?
Plastic water bottles.
Yeah, this just basic water bottle. I mean,
Yeah.
that in the shops, right? I'm not
No,
talking
just
about
water bottles.
huh?
Just like plastic water bottles.
Yeah, okay. Plastic water bottles, and so write down as examples. plastic water bottles and food containers. Food containers, right? That's another name, right? Pet. Yeah, we call it as pet bottle or something, right? Because it's pet, ne? PET, pet bottles. Right, food containers. Okay, then write down nylon. No? Right, here nylon is a kind of a bigger molecule, right? So therefore they just uh, actually you don't need the middle part, right? Here the important part is the polymerization process, right? So as previous, I'll draw the common structure, right? How about the weather condition in your area? Is there a El Nino drought season in
No,
Australia? I saw some news.
no.
Not in your area, right?
No, it must be old news because our weather's fine.
Then it's okay. I saw some news. I mean, they said, I mean,
That must be
Australia
old
effect.
news.
Huh?
That must be old news. We had one like a long time ago.
Ah, the square shows the middle part. Huh?
Okay.
Right. So what is the repeating unit here? right before that, it shows the amide group. This is amide group. Right?
Yeah.
Here you can see carbon nitrogen bond. Previously, it's joined by carbon oxygen bonds, right? Here, the joint made by carbon nitrogen,
Mhm.
right? Here, this part is called dicarboxylic acid, diamine. It doesn't matter, right? The name. So, before that, write down a sentence, right? Write down a sentence.
Yeah.
Monomer contain monomer contain monomer contain two amide two amide groups, also, two amides two amide groups also. Monomer contain two amide groups polymerize with polymerize with polymerize with dicarboxylic dicarboxylic monomers dicarboxylic monomers. Dicarboxylic monomers. In this process, polyamides form. 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 Polyamides form. Right? Polyamides form, and water molecule is released. Water molecule is released. Okay, then write down. Write down this. After that, combine these two polymers. Huh?
Okay.
combine these two. This is the real nylon molecule.
Okay. Okay.
Finish.
Yeah.
Right. Same thing, right? So I don't draw that. Then there are three type of polymers based on their heating and thermal properties, right? Based on the thermal properties, right? Sorry, not
Yeah.
three, I mean two types, right? So those are called thermoplastics and um, thermosettings, right? Thermoplastic and thermosetting, right? Thermoplast, thermoplast means this is a common type of polymer, right? So basically, what happened? These polymers are melting, right? These polymers are melting when you heat it, right? You know that. I mean, that's the. I mean, think about a plastic, right? Normal plastic. When you heat it, it's getting melt, right? After that,
Yeah.
after cool down, again, it's become solidified, right? Does anything happen to the chemical structure? No, nothing happened to the chemical structure, right? Chemical property, right? I mean,
Mm-hmm.
the compound stays same, it just melting and then solidifying, right? So we use this type of polymers, thermoplast, to reshape, right? Or to make new compounds using a mold, right? Put the compound into the mold and then make it, right? So that's what we do generally, right? So then most of the time, I mean, we use that type of plastics to make different shapes, right? There is a mold, then put the molten plastic into the shape, and then when it's cool down, it's become a solid shape, right? And 3D printing,
Yeah.
3D printing, right? Most of the time they use this type of plastic for 3D printing. In 3D printing, they just melt down the plastic and then make 3D structures, right? That's what happens. Simply. So they use this type of thermoplast, right? Melt
Mm-hmm.
down, melt down when you heat, and solidified when it's cooled down. Nothing happened to the chemical properties, right? Chemical structure doesn't change, right? It
Yeah.
stays same, right? There's another type which is called thermosetting. Thermosetting. Thermosetting is different. In thermosetting, this type of plastics are resist to heat, right? This type of plastics are resist to heat, but the problem after that it's maximum level, right? Maximum
Mm-hmm.
capacity, the plastic, the chemical structure of the plastic is breakdown, right? So you can't reverse the process. I mean, you can't get back the same polymer after you heat it, right?
Yeah.
That polymer is
Yeah.
changed, right? That polymer chemical property is changing, right? In that one, the first one, it just melt and then go back to the same chemical properties, I mean the chemical structure, but thermosetting, it is resist than thermoplastics, right? It has some higher melting point, but after it's melt, it just change the chemical structure, right? That's the true difference between thermosetting and thermoplast. There's another type of polymer called elastomers. Elastomers are kind of a different one. Elastomers have ability to, elastics, right? The name, what's the name? When you apply a force, right? When you stretch it, the length is increasing, right? Then
Yeah.
when you release it, it goes back to the same structure, right? That's the term elastomer, right? They may ask about those terms.
Okay.
Even the last exam I faced in my university, right? I got the same question, right?
Oh, really?
Explain thermosettings, thermoplast, and elastomers, right? I got the same
Yeah.
question, right? So it's a very common question, they ask about that, right? So thermosetting, right? So keep it in your mind,
Yeah.
it's simple, right? I mean, thermoplast just melt and then get the uh, just solidified, right? No any chemical changes. But thermosetting, after you heat it, it's change its chemical structure, right? And you can't reverse it, right? It's not just solidifying, right? It's become a
Mhm.
different compound, right? You
Yeah.
can't use it like thermoplast. And elastomers means it's just elastic polymer, right? Just elastic
Mhm.
polymer, that's it, right? No any relation with the heat, right? Okay. Then, so let's write down something about that. Like, okay, can you explain it? I'll give a question and just explain it at home.
Okay.
Write, write down, write down a question. Explain the following polymers. Explain the following polymers.
Yeah.
First one, thermoplastic, thermoplastic, thermoplastic.
Mhm.
Then second one, thermosetting, thermosetting, thermosetting,
Mhm. Yep.
thermosetting. Third one, second one, thermosetting polymers. Third one, elastomers, elastomers, right? So the difference between thermosetting and thermoplastic when we goes to is it's I mean the bonding structure, right?
Mhm.
Thermoplastic have crosslinks, right? Crosslinks, not the normal covalent bond, right? I mean, this is the polymer chain, right? They just arrange like this, right? Those polymers arrange like this. Then they make crosslinks, right?
Yeah.
Crosslinks like this, right?
Mhm.
So the difference is in thermoplastic, these crosslinks are intermolecular interactions, right? Basically, not covalent bonds, right? These
Yeah.
crosslinks are not covalent in thermoplastic, right? That's the difference, right? That's the main reason for all those properties, right? Thermoplastic, right? But when you goes to thermosetting, these crosslinks are covalent bonds, right? These crosslinks are covalent, right? Then if it's break, what happen? If it's break, it's break, right? it, it's not form again, right? When you heat, at one point, these in thermoplastic, these crosslinks are covalent, right? At one point that covalent bonds break. After it's break, it's not form again easily, right? But
Yeah.
thermoplast, these bonds are intermolecular interactions, like I mean, not hydrogen bonds, but like I mean, intermolecular interactions, right? So it form again, right? It form easily. That's why it goes back to the same structure. Clear?
Mm-hmm. Yeah.
That's the main difference, right? When you go to the chemical structure, right? I mean molecular structure, right? So explain it by yourself. Huh?
Okay.
Then organic is over.
Oh, okay.
Yeah, it's completely finished, right?
Yeah.
So
We have trials in like 35 days.
what you have trials?
We have
What?
trials in 35 days.
What is it? I don't know.
Oh, it's like mocks, like mock exams.
Mock exam. Right,
Yeah.
right, right. Mock exam.
It's on module 5, 6, 7, and it's just 8.2. 8.2 from module 8. So not the whole module 8, just 8.2.
Let me check. 8.2
Mm-hmm.
up to 8.2.
No, just module 5, 6, 7, and only 8.2 from module 8.
5, 6, 7, 5, 6, 7, and only 8.2. Only
Yeah,
8.2.
yeah.
All right, not 8.1. But in your exam, I mean, everything is common, I mean,
In the
8.1
main,
and
the
everything.
last exam, everything is coming.
Right, right, right. So, okay. So, 5, 6, 7. 5 equilibrium and reaction. When you mock exam held on?
The date, wait, let me check.
I mean, just around, I mean, which month? I mean, not
It's
next month?
like, no, it's like August, second
Right,
week of
right.
August.
Ah, it's okay. It's okay. We have time. We have enough time. So, before you do anything, right? So, do you have any questions in organic chemistry part? Any thing that you can't understand or any problems?
Uh, no, not really. I just have to practice more the reaction
Yeah,
pathway.
the reactions and
Yeah.
molecules. Yeah, yeah. I mean, if you understand all those things, then you can do that. So I mean, you can practice it by yourself, right?
Yeah.
So actually, there's no any hard things, ne? I mean, no any complicated things, right? Those are easy, ne? You have to memorize those things. Some things,
Yeah.
when you practice it, it doesn't matter, right? So the important part is, so they ask about that boiling points and melting points. I mean, boiling points especially, right? They ask to
Mhm.
compare those things, and then that reactions, right? That reactions
Yeah.
and solubility, right? Solubility, boiling point, and uh, basic reactions, right?
Yeah.
And
Oh,
the final that
my ex so my exam's on the 7th of August.
7th of August. Then it's
Yeah.
okay. We have enough
Yeah.
time.
Yeah.
Let's do is normal may order, right? It's okay.
Okay.
So then the polymer is easy. Polymer doesn't matter, right? I mean the basic things, polymers.
Yeah.
So the hard thing, the complicated thing, the only complicated thing in this part, that reaction pathways, I
Yeah.
guess. Yeah, that's the only complicated thing. When we do question it, I mean, if you remember those reactions, then it's easy, right? So
Mm-hmm.
just practice those reactions, and then let's do some reaction pathways, basic reaction pathways, right? Otherwise, it's easy, right? I mean, the other things are not. I mean, it's not complicated. Mm, right. In school, is this over?
Yeah, module 7 they just finished yesterday, Friday.
Oh, really? Right, right. So You can now you can understand when they teach, ne? I mean,
Yeah,
you
yeah.
can. Okay. Um, can you do it better than others? Huh? Isn't there a competition? I mean, you should do better than others, right? You learn from us, ne, right? They just they only learn from them, ne? Right. Then we can start the applying chemical ideas. Before that, there's a huge chapter review, right? So,
Yep.
sorry, module 7 review. Module 7 review. It's better to complete that module 7 review, Daru. Right? There are some
Yeah.
good questions. I mean, MC multiple choice questions and
Hmm.
I mean, short answer questions. Several short
Yeah.
answer questions. So, just do it at home, right?
Okay.
Module 7 review, right? Then it's easy,
Hmm.
right? Then you can clarify what are the things that you missed and everything, right?
Yeah. Hmm.
Then, I mean, just do it and then we can discuss it, right? I mean, the things that you can't do, right?
Yeah.
I mean, most of the questions are very easy, right? Then
Hmm.
just do it and then we can discuss it. I'll discuss it, right? Is that
Hmm.
okay? Hmm?
Yeah. Yeah.
You can do it, right?
Yeah.
Mm, right. Chapter 7 review. Okay. Then we can start analyzing. I mean, what is that? Applying, applying chemical ideas. Module
Hmm.
8, right? Then module 8, I mean, the first part is analyzing inorganic ions, right? Analyzing
Yeah.
inorganic ions. So, I mean, are you doing practicals in the school? I mean, are they doing
Uh,
practicals?
yeah, we do practicals.
Mm-hmm. They just showing the practical, or they just let you do the practical, or how it's going?
We do it.
Ah, good, good. What are the practicals you did there?
Um, well, some time ago we did esterification.
Uh huh.
Um, and yeah,
That's
that's like
it.
the most.
Uh
No,
huh.
we did more before, but that's like the
Uh huh.
most
Earlier.
recent. Yeah.
Ah, right, right. So, did you smell that? Did you get a good
Yeah.
smell in esterification?
Yeah. Like
Right? It
banana
gives a
smells and stuff.
banana
Yeah.
banana smell.
Yeah.
Ah, good, good. Right. Okay, then let's move to the next part. Analyzing inorganic substances. Right. Here, first let's talk about what we're gonna do here. Right. Basically, this part, the whole thing about here, um, it's based on analysis, right? Analysis,
Hmm.
right? In chemistry, there's a specific part called analyzing, right? I mean, chemical analysis, right? There are some MScs, PhDs also, right? It's a one area, right? Organic is one area of chemistry, right? Analyzing is a one field of chemistry, right? Organic is one field, right? I mean, so there are a lot of things there, right? So why this analyzing is important, first thing, right?
Yeah.
So basically, most of the time we don't know about the when you find something, right? When you found anything, right? I mean, let's say you got a sample, right? I mean, let's say think like this. There is a disease in your area, right? So
Hmm.
we know nothing. We don't know any reason, right? Then we
Yeah.
have to find the reason, right? So then what we can do? We have to find out everything, right? We have to collect things, right? So the basic most of the time, the first thing that we goes for the food and water, right? So then
Yeah.
we have to check those things, right?
Mm-hmm.
That's what you call analysis simply, right? So
Yeah.
then we have to find out, is there any bacteria or anything or any toxic compounds there, right? So we need analysis for that, right? So basically when we analyze chemical substances, we call it chemical analysis, right? We analyze everything, right? I mean, in biologically we analyze that bacteria, fungus, that kind of things, right? So here we talk about chemicals, right? Chemical analysis. Now there are different type of complicated and simple methods to analyze those things, right? So
Yeah.
most of the time uh, it's important with water, right? To check the water. And it's, I mean, when you, I mean, uh, example, I mean, I don't know whether you have well or not, right? I mean, here we have wells, right? I mean, we take the water from our house, I mean, garden, right? So uh, especially in when they distribute water like yours, so
Mm.
they just check those things, right? You need analysis,
Yeah.
right? So yeah, that's it, right? So in analysis there are main two things. I mean, it's divided into two types mainly. We call, have you heard about qualitative analysis and quantitative analysis?
Yeah.
What is the difference between those two, qualitative analysis and quantitative
Quantitative is
analysis?
like to do with numbers and like measuring, but
Yeah.
qualitative is like observing.
Yeah, just identify, right, what present or what's absent, right? So that's qualitative. Okay,
Mhm.
good. Right, so here generally we do the qualitative first, right? So we find out whether it's present or not, then we goes to quantitative, right? We identify whether it's present or not, then we find out how much, right? How much percent. That's what we do. Right, here in this part, we, the first part, it's inorganic, right? We talk about inorganic ions and those things. After that we talk about organic, right?
Mhm.
Organic analysis, right? There are different methods for that, right? So here in the textbook they talk about, I mean, mainly water, right? I mean, it's important for water, right? Do you
Mhm.
know what is called hard water?
Uh,
Hard water.
oh yeah, hard water, soft water.
Yeah, you know
Hard
any?
water is
What
like
is hard water?
lots of like minerals.
Yeah, hard water contain lots of minerals, right, and salts, right? So there are two type of hardness in the water, right? I mean, one hardness, I mean, there's a one that you can easily remove. I mean, easily remove is you can heat it and then you can remove it, but there's other type which not remove by heating, right?
Mhm.
So you have to filter it, right? You can't drink
Yeah.
hard water, right? Even you can't wash, right? Soap doesn't work under hard water, with hard water,
Mhm.
right? Okay,
Yeah.
so right then so this analysis is very important nowadays, because I mean, when you come to water, right, when you come to water, it's very important because um, we remove a lot of toxic compounds into the water, right? Early
Mhm.
days it doesn't matter, right? I mean, early days the problem that we have before industrial era, right, before industrial revolution, the problem that we have, what, bacterial, fungal, right, that kind of diseases, right, with water, right?
Yeah.
We don't have any problem with pollution, right? There's no any pollution, right,
Mhm.
before industrial revolution, right? After that, now we don't have, I mean, still we have, but I mean, we have, the main problem is pollution, right? Water pollution, right? Early days we
Mhm.
have problem with bacteria and basically biological problems, right? So
Mhm.
nowadays we
Yeah.
don't have any biological, I mean, we have biological problems, but the main one become uh, it's made by us, right? Pollution. So therefore these analyses are very important when it comes to water, right? I mean, uh, people, I mean, industry release some water, I mean, the wastewater, right? So there are a lot of things there, right? We can't talk one by one, those are very complicated, but basically this analysis is very important when we come to water, right? So even when they release water, they have to study, I mean, there are some lot of rules now, right? They can't just release pollutions into the toxic chemicals into the water, I mean direct water, right? So they have to filter it, and they have to we call wastewater treatments, right? There are a lot of things, right? So and another thing, the about water nowadays, pollution due to the heavy metals. Do you know what is called heavy metals?
Yeah.
What are the heavy metals that you know?
Uh, just like metals, like heavy metals.
Heavy metals means, is it heavy?
No,
then,
like
then what?
it's like metals.
Okay.
Like mercury
Okay, mercury. Okay, how it become heavy metal?
because it's toxic.
Okay, toxic. Toxic isn't enough to become heavy metal, right? There are a lot of chemicals that, I mean, metals are toxic but not heavy metals.
Yeah. Okay.
So how things getting heavy metal, right? Uh, not because of heavy, right? Not because of the molecular weight, right? So this type of metals, don't you remember something called? I mean, in biology, have you heard about biomagnification or something?
No.
No, which is like there's another name also on it. This type of metals are concentrating over food chains. Have you heard about that?
Yeah.
There are some compounds, not only heavy metals, right? Heavy metal is a one type, right? I mean, that's the common one. There are some chemicals also, right? That chemicals concentrated through the food chain, right?
Mm-hmm.
Do you know that? It's a
Yeah.
it's happened like this. I mean, let's say, so industries release heavy metals into the water river, right? Then
Mm-hmm.
planktons and algae in the river absorb that heavy metals. Does anything happen to the algae? Basically, nothing happened, right? Nothing happened. So fishes eat, I mean, let's say one fish, right? Take one fish, right? One fish
Yeah.
eat hundreds of algae, right?
Mm-hmm.
One algae contain small amount. Then one fish eat hundreds of algae. Then lot of heavy metal goes to the that fish body, right? Then there is another fish which is a big one. I mean, not fish. I mean, let's say there's a uh, bird, right? There's a bird. That bird eat hundreds of fishes in his lifetime. Then what? Now, lot of heavy metals goes to the goes to that bird's body, right?
Yeah.
So can you understand the problem of these heavy metals? It's not recycling, right? Other compounds that we eat, right? I mean, that we take into our body, it's recycling, right?
Mm-hmm.
It's recycling. But this one, it's concentrating, right? Let's
Yeah.
say there is another animal who's eating that bird. That animal eats several birds, I mean hundreds of birds in his lifetime. Then
Mm-hmm.
who's got the problem? The one in the top of the food chain, right?
It's like spreading.
Animals,
Yeah.
yeah, it's concentrating, right?
Mm.
So we are also in the top of the food chain, right? Let's
Yeah.
say we are eating hundreds of fishes, right? One fish contains a small amount, but when we eat hundreds of fishes, we got huge amount of heavy metals, right? Not only heavy
Yeah.
metals, but there are some compounds, right? So that type of metals we call heavy metals. Those aren't recycling and not recycling. Instead of recycling, it's just concentrating, right?
Yeah.
That's the idea of heavy metals. Huh? So just keep it in your mind, right? I mean, it's a biology one. But
Yeah.
to become heavy metal, that metal need that property, right? Concentrating, right? Not recycling. Um, Mercury, cadmium, uh, mercury, cadmium, arsenic, right? Do you know arsenic, right? Those are heavy
Yeah.
metals, right? Then, so we need these analysis methods to identify those heavy metals and that compounds, right? Here we focus on inorganic ions, basic
Mm-hmm.
ions, right? So first we talk about the qualitative analysis, right? So qualitative analysis means just find out whether it's present or not, right? That's
Yeah.
it. So what are the methods that we can use to identify inorganic ions? Inorganic ions. What are the methods that we can use? Basically, the simple methods. Those are basic identification methods, right? Um, we can use some chemicals, and let's say, I mean, give me example. Let me give example. Let's say something like, let's say sulfate, right? Sulfate is iron, right? If you want to identify sulfate, right, you can put barium chloride into the sample, right? You can put barium chloride into the sample. When you put barium chloride, it gives a barium sulfate, right? Barium sulfate is a precipitate, right? White color precipitate. Then still you can't say it's a barium sulfate, right? But if it's make a precipitate, you can add acid, right? If you add
Yeah.
acid, if that precipitate is not dissolved, you can definitely say that's barium sulfate. Those are very simple things. Huh? There are some compounds that gives colors. Okay, example, um, especially D block. You know D block ions, D block metals. D block metals gives color, right? Colors with different compounds. I mean, with ammonia, with HCl, right? So they give different colors, right? Color changes. Then you can again identify. But there is a problem in this kind of cases. You need some amount of, I mean, a little bit higher concentration, right? Not that much high, but it should show the color, right? To show the color, there is a minimum concentration, right? Otherwise, it doesn't show the color change, right?
Yeah.
So nowadays, I mean, those are very simple reactions that we do in the laboratory, right? In industrially, in industrial level, now we have different test kits, right? That test kit have some compounds, right? So what you have to do, just take the, sometimes they have papers, sometimes they have chemical powders, right? You just take the sample and mix with the sample, and then you can identify, right? So
Yeah.
that kind of methods, easy methods used in industry, right? I mean, nowadays, right? In laboratory, you can use that chemicals, right? You can easily identify using those chemicals. Another example, colors. I mean, when you goes to colors, do you know flame test,
Yeah.
right? What is flame test?
The it like you have to like put metals on a rod and then you put them onto like
Yeah,
onto
yeah,
like
yeah,
a
yeah.
flame.
What type of metals gives the color change?
Like
Which type?
metals like copper gives like a blue-green color, barium is like
Yeah,
a and stuff.
yeah, yeah,
And
yeah,
it's
yeah,
because the
exactly.
electrons are falling from different levels.
Good, good, good. Right, you know the theory, right? So metals gives color change, right? Flame test also one thing. Especially we use flame test for the first and second group metals because they don't show any color changes with the, I mean, color change when it's in aqueous form, right?
Yeah.
It's rare, right? Metals like sodium, potassium, magnesium, they don't show any color changes like D block. D block element shows color change with the color change when they in the aqueous solution, right? First
Yeah.
and second group doesn't show any color change. I mean, they show rarely, even it shows because of the anion, right? Otherwise, it doesn't show any color changes. It's rare
Yeah.
showing colors, right? So, therefore, most of the time we use flame test for identify first and second group. Okay,
Yeah.
because it's easy, right? I mean, it doesn't give the colors in aqueous, but it gives color change for the flame test, right?
Yeah.
Even we use that, I mean, metals like sodium for the lamps also, right? Why? Because of the color, right? It gives that yellow color, right? So therefore we use it for lamps, right? So Even people use this for you know that firecrackers, right? What you call that? මොනවද මල් වෙඩි කියන්නේ අර උඩ යවන්න මොනවද මේ events වල
Firework. Firework.
fireworks, right? So they use these metals for take the colors, right? That's how they take the colors, right? When that metal burn, it gives that color. That's how they make color fireworks, right? So just write down the main topic, qualitative techniques for detecting salts, right? Qualitative techniques for detecting salts. Qualitative techniques for detecting salts. Right. So basically,
Yeah.
we use precipitation and color changes to identify those ions, right? We get the
Yeah.
precipitate and do something, right? Or we just see the color change directly, right? That kind of things, right? So write down the subtopic precipitation, right? Subtopic precipitation, right? So here we're going to talk about different type of precipitation. Right. Here so example for precipitation, right? Let's say you have a water filter, right? Water filter that remove sodium chloride, right?
Yeah.
That remove sodium chloride, right? So then you need to check whether that filter works properly or not. I mean, whether it release sodium chloride completely or not, right? So what we can do, we can use a compound or chemical that gives a color change when sodium chloride, right? I mean, this is sodium chloride, NaCl, right?
Yeah.
Here, just keep it in your mind from the beginning. When we analyze, I mean, here it's a complete salt. When we analyze one part, right? Sodium or chlorine, right? So,
Yeah.
think how do we find out whether that filter work properly or not? We have to check sodium ion or chlorine ion, right? We
Yeah.
have to check chlorine ion or sodium ion. We can't check it, I mean, the complete compound, right? If 1%, if one ion present, I mean sodium or chlorine present, means complete salt present, right? That's the idea here, right? So find a method, we have to find a method to test one, right? Testing one is enough, right? One ion is enough, right? So now just think about a practical situation, right? You need to check the water sample, I mean the filtered water, whether it's contain sodium chloride or not, right? So how to check that? You can use flame test. Why? This one contains sodium, ne? You can easily put the metal, I mean that dip it in the water and then put into the flame test, right? If there's sodium, it will give the color change. Easy, not complicated, right? So you can check sodium like that, right? Then if it give the color change, you can say, oh, okay, filter doesn't work properly, right? It's not filled, it's not removed sodium chloride effectively, right? Then again you can check the chlorine ion also, right? You can check the chlorine ion also. How to check that? You can check the chlorine ion by adding silver nitrate plus, right? You can add silver nitrate, then if sodium chloride present, what will happen? It forms AgCl, which is a precipitate, white precipitate. Clear?
Yeah.
So keep it in your mind. Most of the time what we do in precipitation, right, especially in precipitation, we just exchange the ions, right? Silver chloride, then sodium nitrate. Understood?
Yeah.
We just exchange ion, and then one salt, it's form a new salt, right? It's form new salts. Then one become a precipitate, right? Some precipitates have colors, some precipitates are white, right? Some precipitates are colorful. I mean, like this one, it's just white, right? But you don't know whether it's exactly how to predict whether it's exactly silver chloride. In this kind of situation, let's say you already know this one contain only sodium chloride, right? I mean, your initial solution contain only sodium chloride and water. I mean, you are filtering only sodium chloride and water. Then no need to do any further investigation, right? This is the investigation, right? If you already know that one contain only water and sodium chloride, then if it gives the white precipitate, you know it's so AgCl. But if you don't know, if you filtering mixture, then it may, you don't, if you don't know what are the ions contained in the initial solution, one test isn't enough, right? There may be another white precipitate, right? Then the best way is doing another reaction, which is, I mean, which is called, I forgot the name. I mean, the next one, whatever, just do the another reaction, right, to check the silver chloride, right? That's what we do, right? Most of the time we do two reactions to finalize it, right? If you know if that one contain only chlorine, then I mean the initial one only contain sodium chloride, then it doesn't matter, right? You are checking this sodium chloride present or not, right? If it gives a white precipitate, the drinking water contain sodium chloride, right? Keep it in your mind. We are checking one ion, right? And we just put something and exchange the ion, and it gives the precipitate. That's what you do in the precipitate, right? Precipitation, right? Right. So write down a sentence. To test, to test, to test, to test, water filter removes sodium chloride effectively. To test, if water filter removes sodium chloride effectively, we can add silver nitrate into the water. Into the water. if chlorine 9%, if chlorine 9%, if chlorine 9%, if chlorine 9%,
Yeah.
if chlorine 9%, it gives white precipitate. It gives white precipitate. It gives white precipitate. Right. Just write down. Right. Then there's another example. Checking cobalt ion, cobalt 2 plus in water, right? Cobalt 2 plus, right? So what we can do, we can add SO4 2 minus, right? So actually even here the salt that we add doesn't matter. I mean the complete one, right? What we need this silver ion, right? Silver ion is the important part because if you can add silver ions anyhow, right? Not as NO3, but I mean the problem is most of the silver ions are, I mean silver compounds are precipitates, right? There are few like silver nitrate are soluble in the water, right? That's why I use silver nitrate, right? Here also sulfate ion, right? It doesn't matter how would you add sulfate ion, but it should be aqueous form, right? Soluble aqueous form, right? Sodium sulfate, potassium sulfate, it doesn't matter, right? You have to send the sulfate ion into the system sample, right? That's the requirement, right? That's why I said just understand. We here what we do, we just combining different ions, right? You have to put the ions, right? Then it's combined with another ion, right? Then it's from precipitate. So here it's from a precipitate, right? So it gives the, yeah, it gives cobalt sulfate. If it's present, it gives the cobalt sulfate, and it has a color also, right? They haven't mentioned the color, right? So basically, and another thing we have to consider the solubility, right? So here why AgCl is precipitate, its solubility is very low, right?
Yeah.
Its solubility have, did you learn something called solubility product in earlier?
Um, we actually skipped that and we're coming back to it after the mock exams, but I learnt about it
You learned it
myself. But for school, we skipped it this year. We're coming back to it after the mock
after the
exam.
mock exam. Ah, right. So if you remember what is that, that explain how things get precipitate, right? This thing is based on that, right? It's related, right? So there's a value called solubility product, I mean KSP, right? KSP. So the precipitates, right, or the precipitate that you're gonna plan to get, right, should have very low KSP value, right? That's how it's become precipitate, right? That's why it's become precipitate. Even without that knowledge, you can understand this, right? So the theory in there, right? The theory in there. Okay. So that's it thing, right? Basically, that's what we do, right? We just put any ion and then it just react with that ion and make a precipitate, right? No any complicated thing. So first and second group elements form lot of, I mean, most of the time white precipitates, right? As I said, right? First and second group elements, I mean ions, I mean metal ions form white precipitates, and silver also, I mean, it's form. Listen. Sometimes that ions gives colors. I mean, I mean the positive ion and negative ion, right? Sometimes
Yeah.
positive ion doesn't affect on the color, the negative ion effect, right? Most of the time, first and second group ions doesn't use color because of the metal ion, I mean positive ion, right?
Yeah.
Sometimes it gives color due to the negative ion, right?
Mm-hmm.
That's what happened. D block elements make colorful precipitates, right? Colorful precipitate, especially with the hydroxide, they show colors, right? I mean, not only hydroxide, um, chlorides, right? Different things. Okay. Right. And those are general things, huh? General.
Yeah.
Uh, just keep it in mind. I mean, sometimes it's change. Okay. Then they gave some colors, right? Common colors, right? Listen, here you have to remember those colors, right? Remember means you don't need to memorize all the colors, but um, you have to remember some basic things and some common colors of precipitates and ions, right?
Yeah.
You have to remember that. Huh? Otherwise,
Mm-hmm.
if they ask to find out something, you can't do that, right? They don't give the colors in the exam, right? They don't give those colors in the exam. So therefore, you have to memorize it. Even I mean, A levels, you have to. If you do A levels here, you have to memorize hundreds of colors, right? Not hundreds, but lot of colors, right? I mean, here it's
Yeah.
few. So just remember, I mean, generally colors shown by D block, right? D block metals, transition elements, right?
Yeah.
Right. Then we have to, I mean, analyze those things, right? Mm. So write down detecting metals using precipitations, right? Subtopic detecting metals using precipitates.
Mm-hmm.
Right. Here, let's say you got any iron, right? You need, you have to check copper, ion, right? You have to check copper ion, whether copper present or not, right?
Yeah.
So what you can do, so you have to identify using precipitation. Okay, let's say you have to identify it using precipitation, right? So you know nothing, right? You know nothing. But if you have um, solubility table, right? Solubility table of copper ions, I mean copper salts, right? You can use that to identify copper, right? Even if you know anything, if you don't know anything, right? So how do you think? You have to think like that, right? First, I mean, here you're going to make a precipitate, right? So then
Mm-hmm.
you have to find out what type of what type of salts are insoluble in water, right? Example, let's say copper hydroxide, right? Copper hydroxide, actually it's not a salt, but I mean, let's say copper hydroxide is insoluble in water. Okay, you found out copper hydroxide is insoluble in water, right?
Yeah.
Insoluble means its solubility product is very low, right? Then what you can do, right? Actually, this part is a not, I mean, this is a investigation part, right? Actually, you don't need to memorize those things. But the problem is, if they don't give any data, there's no any, I mean, you can't, I mean, you have to memorize it, right? In the exam, that's the problem. I mean, otherwise, you don't need to memorize those things, right? There are some tables, okay? Let's say you found out copper hydroxide is insoluble in water. Then how to use that knowledge to identify copper ion? You found out copper hydroxide is insoluble in water, right? So then how to use that knowledge to identify copper? Let's say you're going to try to find copper, then I mean you try to identify copper, right? In the sample,
Yeah.
water sample, let's say water sample. What do? You have to add OH minus ions into the solution, right?
Oh,
You have to
okay.
add OH minus ions into the solution. Anyhow, it doesn't matter, right? Most of the time it doesn't matter. You have to add OH minus ions into the solution, then what will happen? It's form copper hydroxide, which is a precipitate, right? It has
Yeah.
a specific color, right? So then if I ask, how do you want to add OH minus ion? You can't add just OH minus ions alone. How would you add OH minus ions into the solution?
Uh,
How?
how?
Hmm? You can
Um,
use a base thing, right? Nothing else. Especially you should use strong base, right? Not like ammonia, right? Don't use ammonia, it gives a different color, right? uh, there's a thing in here, right? If you put more ammonia, it doesn't form that copper hydroxide, right? If you put more ammonia, right? So the safe
yeah.
thing is put strong acid, right? Drops of strong acid. If copper present, that OH minus make a precipitate. Understood,
Yeah.
right? And the speciality of that precipitate, it doesn't dissolve with more OH minus ions, right? So
Yeah.
then another example. Is it clear? Right? Is it clear?
Yeah. Yeah.
Right. This is an investigation thing, right? There's no any exact way, right? I mean, there are several ways, right? So copper hydroxide is blue, right? So you need that solubility, right? Idea about the solubility, right? This is a very simple thing, right? Then another example, okay. As I said, how to identify? Let's say how to identify barium. Tell me a way to identify barium.
Well, the
There are
flame
some.
test.
Okay, flame test. Okay, what
The
else?
flame
Using
test.
precipitation. You don't have a burner. Let's say you don't have a burner. What do? If you don't have a burner? Remember, I told you we can identify sulfate using barium chloride.
Yeah.
If you have barium chloride, I mean, if you want to check so
Oh, so
sulfate
then you
ion,
can use sulfate for barium.
good, you got a brain, right? So it's from barium sulfate, right? So which is a precipitate, right? So again, if you want to identify barium, what you can do? Add
Sulfate.
sulfate separately, right? Then it's from barium sulfate, which is a white precipitate, right? and the specialty of that white precipitate, which is insoluble in acids, right? It's
Yeah.
insoluble in acids, right? Understood?
Yeah.
That's the idea, right? So if you know one thing, then you can that knowledge into another thing to identify, right?
Yeah.
Clear?
Mhm.
Right. Then those are common examples. I mean, that's the way. That's the way you use this, right? Precipitation, right? You have to consider about the precipitation, and then you have to continue. Here, the next part is we have to talk about Lotta.
Mhm.
So I don't have time today. So
Yeah.
I'll stop at here, right? So the next part is, I mean, here there's a chart, right? So I mean, if we have several ions, how do we divide it, right? So I'll stop at here.
Mhm.
So then next week I'll continue this part, right?
Okay.
So complete that chapter review, right? Complete
Oh
that
yeah.
chapter review.
Mhm.
Complete that chapter review at home. When you, if you got any question, just text me. I mean, call me or
Okay.
text me, whatever, right?
Okay.
Ask me.
Okay. Okay.
Uh, right. Okay. Okay, you
Oh,
can.
okay. Oh, okay. Thank you.
Okay, bye.
Thanks. Bye bye.